All right, 5.5, solving equations by graphing. So this one's kind of like what we did in, I think it was section 1, where we solved to graph, but it's going to be just a little bit different. So to solve the equation f of x equals g of x, we're going to write the equations like f of x equals g of x. And then what we can do there is we can graph them kind of separately and solve. Normally, whenever we have something like this, we'll solve it by hand by like adding our x's using algebra. But we are able to solve them by graphing. So this is just kind of a different way to do this. Um, yeah. So let's look at number or example 17. So this should be 2x plus 4 equals negative x minus 5. Now, what I'm going to do here is I'm going to say, well, y equals 2x plus 4, and then y equals negative x minus 5, and I'm going to solve it. Or I'm going to graph it and then solve. So let me see if I can graph this nicely. I have, starting off, I'll do the left one in orange. I have an intercept of 4 and a slope of 2. So here's my orange line. And I'll do the other one in green. So I have an intercept at negative 5, 1, 2, 3, 4, 5, and a slope of negative 1. So it would go right like this. My solution is going to be 1, 2, 3, negative 3. I'm finding the crossing of the lines, but really what I care about is just the x value of it in this scenario, right? So this is the point negative 3, negative 2, but I really just care about the x, so x equals negative 3. And we can look at this, and if we were to solve this by hand, we would get 2x plus 4 equals negative x minus 5, which would be 3x equals negative 9, so x equals negative 3. All right, that's one that we could solve by hand. Right. Next up, we're getting one that's a little bit more difficult to solve by hand. We still could, but it's more difficult. So that's what we're doing here. My answer here is x equals negative 3. And I'll count this as checking my solution. Later on, I'm going to plug back in and make sure that it's correct. Let's look at example 18. Let me scooch this so that we have more space. This should be 3x plus 6 equals x minus 2. So I'm going to have y equals the left piece, and I'm going to graph it, and then I'm going to graph the right piece. The green one would actually be a little bit easier to graph. We remember that it's x minus 2, which means it's shifted right 2 spots, and it's just going to be up 1 and over 1. So there's the green equation. The orange one we're actually going to need to do a little t-chart for. I'll plug in, I don't know, what should I plug in? 0, 1, 2, and 3 maybe. Maybe I should go on the other side of it. I'll do negative 3, negative 2, negative 1, and 0. If I plug into negative 3, I'd have 3 times negative 3, which is negative 9, plus 6, so that would make it negative 3, and then absolute value makes it positive. Negative 2 I plug in, 3 times negative 2 is negative 6, plus 6 is 0. Negative 1, 3 times negative 1 is negative 3, plus 6 would be positive 3, and then 0 would give me 6. So I have negative 3, 3, negative 2, 0, negative 1, 3, and 0, 6. So it looks like my solution is right there at the point negative 1, 3. but we really only care about the x value in this scenario. Let's plug that back in and make sure that that is correct. So we would have absolute value of 3 times negative 1 plus 6 equals, and we want to see, is it equal to negative 1 minus 2? 3 times negative 1 would be negative 3 plus 6 equals negative 1, or excuse me, negative 3. So this would be 3, or absolute value of 3 equals absolute value of negative 3. So that's true. But look up here. I think we're going to have another spot where they cross right up there. That would be at negative, what would that be? At negative 4, 1, 2, 3, 4, 5, 6. So let's check the negative 4 out now, and we'll make sure that that's correct as well. That would be, to plug that back in, I'd have 3 times negative 4 plus 6. And I want to know, is that equal to absolute value of negative 4 minus 2? 3 times negative 4 is negative 12 plus 6, and that would be negative 6. And there we have it. The absolute value of negative 6 is equal to the absolute value of negative 6. So my solutions are x equals negative 4 and negative 1. So we have both of those are our solutions to that. All right, example 19. Let me scroll down a little bit. Solve by graphing, check your solutions. This is negative x equals x minus 4. So if we were to solve this by graphing, I draw my little graph here. The left piece is y equals negative x, so that would have an intercept of 0, and my slope is going down. So it'd be a line like that. My other one would have an intercept of negative 4 and a positive slope, so it'd be like this. My solution would be at positive 2, so x equals 2. I want to plug in just to make sure that's correct. I'd have negative 2 equals 2 minus 4, and that is a true statement. So there it is. My answer is x equals 2. I recognize that this equation here, that this problem here, would probably be easier to solve just straightforward, but we're trying to learn a new method. We're trying to learn how to graph them. So I would like you to graph them on your homework. Example 20. Example 20, this would be 1/3 x plus 1 equals x minus 3. If I were to graph this, the left piece would have an intercept of 1 and a slope of 1/3. So I'd go up 1 and over 3, down 1 and left 3. The other line would have an intercept at negative 3 there with a slope of 1. It'd be like that. And just to make sure, I'm going to go back to this orange point here. Slope of 1/3, so up 1 and over 3. Yep, so there's my point. That would be at 1, 2, 3, 4, 5, 6. So x equals 6. Checking my answer, I can plug back in. I'd have 1/3 times 6 plus 1 equals 6 minus 3. 1/3 times 6 is 2 plus 1, and then 6 minus 3 is 3. And that is a true statement. So x equals 6 is my answer. Example 21. We want to solve and graph this with a graphing calculator. That's going to be something that I'm going to need to show you guys in person. If you'd like to, you can find a YouTube video over it. But all we're going to do is graph it, but with the calculator, and then the calculator has a nice way to find where things intersect. You could do this by hand by doing a T-chart for both of these, but I'm not going to do this problem because I want to save it for in class with the graphing calculator. So, all right, that is all with these. Make sure you've got this example down. This is probably the most difficult one that we did, and good luck on the homework.